Okay, so let's continue with chapter 3, section 3.5. It's about implicit differentiation. So what exactly is implicit differentiation? Well, all the derivatives that we've been doing are actually called explicit differentiation. Why explicit? Because y was always a function of x. It was y equal f of x. Implicit, it doesn't have to be that way, okay? So for example, like y equals x squared plus y squared equals 7. So you can see y is not isolated, y is isolated. Like y equals 1 over x plus square root of xy equals 1. So how do we find the derivative when y is not isolated? That's basically the objective of implicit differentiation. Just to give you an idea, so if I'm giving you an example of a function and then its derivative with respect to x with regards to x, respect to x. So if the function is y equals x squared plus 1, then its derivative dy by dx is the derivative with respect to x of x squared plus 1 equals 2x. Now if I want to square that, so y squared is x squared plus 1 squared, so dy by dx, it's going to be the derivative of x squared plus 1 squared, which according to chain rule, it's 2 x squared plus 1 to the first power times the derivative of x squared, which is 2 y prime. So derivative of with respect to x of y squared is 2y prime. Just like derivative with respect to x of u squared, according to chain rule, it's 2u prime. So derivative with respect to x of y squared is 2y prime. Okay, so be careful. We're not talking about x squared. If it was derivative of x squared, it's 2x x prime, of course, but x prime is 1. That's why we do that. X prime is dx, which is 1. So in general, when you're doing implicit differentiation and you do derivative of y to the n, whatever n is, it's going to be n y to the n minus 1, but then you get to times it by y prime thanks to the chain rule. And also, derivative of x with respect to x is dx by dx, which is 1. Derivative of y with respect to x, it's not 1, it's dy by dx, which is y prime. So when you're finding the derivative of y with respect to x, it's not 1, it's y prime. Keep that in mind. So what are the guidelines for implicit differentiation? Here I have this in your notes. You don't have to write it down. Okay, and I'm going to go over this. It's this. So the first thing to do implicit differentiation, and then I'm showing you an example on each step. Differentiate both sides of the equation with respect to the independent variable. In general, it's x and have to be x. So you do prime on both sides. Okay, if two functions are equal, then their slopes are equal. Okay, derivative of x cubed plus y cubed, again the sum. So you do derivative of x cubed 3x squared x prime, but x prime is 1. That's why we don't do that. Derivative of y cubed is 3y squared y prime. Y prime is not 1, it's dy by dx. dy doesn't cancel dx out. Derivative of y is y prime. Derivative of 3 is 0. Collect all y prime terms on side of the equation because you want to isolate y prime. All other sides on the opposite side. So these two have y prime. We're going to put them together. And this doesn't have y prime. It's separated from these two. Factor out y prime. We did. And then isolate y prime. And that's going to be your y prime. And notice that y prime is a function of x and y. When we did explicit, it was always a function of x. Now it could be a function of x and y itself. That's very important. Okay, so page 214, number 6. Page 214, number 6. So we have 2x squared plus xy minus y squared equals 2, and we want to find y prime implicitly because y is not isolated, so we do derivative of the left side equals derivative of the right side. 2x squared is 4x x prime, but x prime is 1. Now this is, you gotta be careful here. It's x is a function of x, y is a function of x. So we're doing the product rule. So fix x times derivative of y plus fix y times derivative of x. Again, x y prime because it's f g prime plus g f prime minus derivative of y squared, power rule to y prime, derivative of any constant is 0. We keep the y prime terms on this side. We're going to move the 4x and the y to the other side so they both become negative. Factor out y prime minus 4x minus y and isolate y prime, and you can see that y prime is a function of x and it's also a function of y. Alright, again find dy by dx explicitly where e to the y sine x equals x plus xy. So the derivative of the left side equals the derivative of the right side. Here we have product rule. So we fix e to the y times derivative of sine x, because sine x times x prime, but x prime is 1. Sine x is fixed, e to the y, its derivative is e to the y times derivative of y, which is y prime. Derivative of x is 1. This is product rule. You fix x times derivative of y, fix y times derivative of x. So this guy and this guy have y prime. We're going to put them together. So I'm going to move this over here. So I have sine x times e to the y times y prime minus xy prime equals 1 plus y. And then we're going to move this guy minus e to the y cosine x. Factor y prime sine x times e to the y minus x. 1 plus y minus e to the y cosine x. Divide. And there's my y prime in terms of x and y over sine x times e to the y minus x. Okay. Few more examples just to practice. Again, find dy by dx explicit implicit. Tangent of x minus y equals y over 1 plus x squared. So we're going to do the derivative of the left side equals the derivative of the right side. Or if you don't want to do it this way, what I did in my notes, I multiplied by 1 plus x squared. So I don't have to do product rule, I would just do the quotient. I wouldn't have to do the quotient rule, I would just do the product rule. It's just a little bit easier that way. So f times g, product rule. So we fix f times derivative of tangent u, it's secant square u times u prime. Derivative of x minus y is 1 minus y prime. So that's f g prime plus g f prime. Derivative of that is 2x equals derivative of y, and as always is y prime, dy by dx. So I have this, all this, times 1 minus y, so we're going to distribute that. So all this times 1 is 1 plus x squared secant square x minus y minus y prime times all that, y prime, because we want to separate the y prime from everything else. So I distributed that. Now minus y prime, I'm moving this over here, and then I'm going to move this guy over there, so negative 2x tangent of x minus y. So this has a y prime, this has a y prime, this doesn't, so I'm going to have y prime, and then negative 1 plus x squared secant square x minus y minus 1 equals negative 2x tangent x minus y minus, I should have done it the other way, but that's okay, secant square x minus y. Get rid of all the negatives by timesing by negative. So you get y prime equals 2x tangent x minus y plus 1 plus x squared secant square x minus y over 1 plus x squared c squared x minus y. So I canceled all the negatives out. Alright. I don't know, I did 29, that's your homework, so I'm gonna leave it. I'm not gonna do 29, but it's done in the notes. The next one, the last one that I want to do is 48 from page 215. X cubed minus y cubed equals 7. They want me to find y prime and then y double prime. Okay, so to find y prime, again derivative, so 3x squared minus 3y squared y prime equals 0. 3 squared equals y squared y prime, so y prime is x squared over y squared, which can be written as x squared y to the negative 2. To do the second derivative, I'd rather do the product rule. So fix x squared, derivative of this guy is negative 2y to the negative 3y prime, plus fix y to the negative 2 times derivative of that. So that's gonna be negative 2x squared y prime over y cubed plus 2x over y squared, which we can actually put x squared over y squared for this guy just to make it nicer. If x squared over y cubed times x squared over y squared, x over y squared, which would be negative 2x to the 4 over y to the 5th plus 2x over y squared, which could be simplified easier, but I mean, which could be negative 14x over y 5th. And that's it for 3.5. Next, we're going to do 3.6.